Hey everyone, and welcome. Have you ever looked up and wondered what really separates, say, a giant blimp from a super fast jet? Well, today we're going to break down the entire world of things that fly into two really basic groups. You're about to get a whole new perspective on flight. I mean, just think about that for a second. On one hand, you've got a hot air balloon. It just drifts, totally silent, this huge, graceful bubble. And on the other, you've got a fighter jet that literally rips through the sky faster than the speed of sound. They seem like they're from different planets. So how in the world can they both be called aircraft? Well, the answer is all about the physics of how they get off the ground in the first place. And here it is. This is the big secret. Every single thing that flies fits into one of these two families. It's either lighter than the air around it, which means it basically floats, or it's heavier than the air, and it has to work really hard to generate its own power to fly. Floating versus flying. That single distinction right there is the key to understanding everything else we're going to talk about. Okay, so let's jump into that first category, the floaters. And I just love this way of thinking about them, like ships on the sea, because that's pretty much exactly what's happening. They aren't flying through the air so much as they're riding on a giant ocean of it. The science that makes this all possible is called buoyancy. And you've seen it before. It's the exact same reason a massive cruise ship doesn't sink in the ocean. The idea is actually pretty simple. If you can make your aircraft weigh less than the big chunk of air it's pushing out of the way, well, physics just takes over and does all the heavy lifting for you. Pretty neat, right? And the most classic example of this, of course, is the balloon. It doesn't matter if it's using hot air, which is less dense than cool air, or a gas like helium. The principle is exactly the same. It's buoyancy in its purest form, which is why balloons are just perfect for sightseeing and quietly enjoying the view. But, what if you want to actually steer your giant balloon? Well, you add some engines and some rudders, and voila, you've got yourself an airship, sometimes called a dirigible. They had this brief kind of glamorous moment back in the day as passenger liners, but because they're slow and not great in bad weather, today you mostly see them floating over stadiums for advertising or as super stable camera platforms. Now, the last member of the floater family is a bit of an oddball because it doesn't really go anywhere at all. A tethered aerostat is basically a big balloon anchored to the ground. It acts like a stationary watchtower way up in the sky, which makes it absolutely perfect for long-term surveillance or scientific research. All right, let's totally switch gears and look at the other side of the family. If you're not floating, you have to be flying. And these are the aircraft we're all familiar with, the ones that are much heavier than air and have to constantly generate their own lift to fight against gravity. So this is where some really clever engineering comes in. Aerodynamic lift is way more active than just floating. It's all about the special curved shape of a wing, which we call an airfoil. As that wing slices through the air, the curve forces the air on top to travel faster than the air on the bottom, and this creates a pressure difference. You get lower pressure on top, higher pressure below, and that difference literally sucks and pushes the wing up into the sky. And even inside this flyer category, there are two main strategies. You can either have wings that are stationary, or fixed, and you move the whole aircraft forward to make lift. That's a fixed-wing aircraft. Or you can keep the aircraft pretty much in one spot and spin the wings themselves. That, of course, is a rotary-wing aircraft. Now, fixed-wing aircraft are really the workhorses of our modern world, and for good reason. By using that forward motion, they can generate a ton of lift, which makes them super efficient, especially at high speeds. This idea scales all the way from tiny private planes up to massive cargo jets and, of course, the airliners that connect our entire planet. It's a design that's been perfected for speed and carrying heavy stuff over really long distances. Then you've got the rotary wing side of things, where the helicopter is the absolute king. Its powered rotor blades are basically just spinning wings. This incredible design lets it do things a plane just can't, like take off straight up, hover in midair, and fly in any direction. It also has a lesser-known cousin called the autogyro. It looks kind of similar, but its top rotor isn't actually powered by the engine. Instead, a propeller pushes it forward, and the air moving up through the rotor makes it spin, kind of like a pinwheel, and that's what generates the lift. So there you have it. We've got our floaters and our flyers. Now let's just bring it all together for a second and really look at how that one fundamental difference, buoyancy versus aerodynamic force, ends up dictating what we use these aircraft for. And this table just lays it out perfectly. On the one hand, you have the lighter-than-air crew. They use that simple, elegant buoyancy. It's fantastic for just hanging out in the sky, which makes them great for recreation, advertising, or surveillance. But they're not fast and they're not powerful. For that, you absolutely need the brute force of aerodynamic lift, which is the foundation for pretty much all modern transportation, cargo, and military planes, where speed and power are everything. So the next time you see something in the sky, you won't just see an aircraft. You'll see the solution to a physics problem. It's either effortlessly floating on the air, or it's powerfully flying through it. And that leaves us with a really fascinating question to think about. As technology moves forward, is the future of flight going to rely on the efficiency of the floaters, the raw power of the flyers, or maybe some kind of new hybrid that gives us the best of both worlds? The sky, quite literally, is the limit.